Welcome back to CCCS 111, Introduction to Programming. Today we start Chapter 3, Structured Program Development in C. So the first few sections of this chapter should be very familiar to you because you have already taken CCCS 100, Introduction to Computer Science, and you spent a good amount of time on learning the norms of developing flowcharts for algorithms. So the first few sections of this chapter basically talk about that until we move on to more material on conditional control flow statements, which like the if statement, the if-else statement, and others. So I'm just going to go through this first part on flowcharts very quickly. I know you have used Flowgorithm in the last semester, so that should come in very handy. So basically, a program is just a description to a solution to a particular problem. We already know that. We have an algorithm is basically a procedure, and we take different actions that are we execute different actions step by step, sometimes conditionally, and in a certain order in order to solve a particular problem. So here's a very simple example of, let's call it the rise and shine algorithm. So we have someone working in an office, junior executive over here, and this is his algorithm for in the morning for getting ready for office. Step 1 is described as get out of bed. Step 2, take off pajamas, take a shower, get dressed, eat breakfast, and carpool to work, in that order, of course. Now, why is the order so important? Because if you mess up, if you change the order indiscriminately, you could end up with something like this. Get out of bed, sure. Take off pajamas, get dressed, take a shower, eat breakfast, carpool to work, that's fine. But if you don't do these in the exact same order, you could end up with someone who who arrives to work soaking wet. So that's this is just to highlight that the order in which instructions are executed matter. Now, to control the order in which statements are executed, specifying that order is done by something called is called program control. Now, before you even write a single line of code, what you usually want to do is you want to be clear about what the solution to your problem is. And one way to express that before writing code is using pseudocode, something you should have also done in CCCS 100. So again, I'm going to go through this very quickly. So pseudocode is not actually code that is executed by computers. Pseudocode can be thought of you basically making notes about developing about basically describe an algorithm. It's about you basically can be you thinking out loud in a sense. But if pseudocode is written well, it should be possible to easily convert it to a corresponding C program. Now, one slight difference is that usually when we express pseudocode steps in pseudocode, those steps usually consist of only actions and decision statements. So what you might be thinking, does that not include? What are we skipping over here? So definitions of variables. So int num1, int integer1, those kinds of things we've been doing. Those are not executable statements. And usually that part, those are skipped when we are writing pseudocode for an algorithm. So this, for example, something that would have to be part of a program using even a single variable. That's something that you would not mention in pseudocode. So instructions or statements are executed in sequentially. We already know that. We've done that. All the programs that we started with, they were basically sequences of statements. But occasionally you want to, and what happens in C, and actually most programming languages, is one statement is by default, after being executed, is followed by the next statement. But occasionally, actually many times, you do not want to do it. You do not want to execute statements strictly sequentially. You want to execute some statements, not others. Maybe you want to execute some statements repeatedly. So in the 60s, what happened was, early on, there was something called a go-to statement. A statement basically that allowed programmers to make control, or the current statement to be executed, to make that point in the program jump from one part to another. It was the early way of achieving control flow in programs. The problem was that it was very hard to debug problems in programs that were using a lot of these go-to statements. So what followed was basically kind of a movement to eliminate the use of the go-to statement. And today, if you learn a new language, no one, very frequently in many courses, they won't even talk about the existence of this go-to statement. And this style of program was, you can call that go-to-less programming. And it was also shown that basically the new program control flow structures that we had, they made it completely unnecessary to use the go-to statement anymore. And they're basically just a limited number of control structures that we can use to basically implement any algorithm. And we'll get to those one by one. So one of them, of course, is sequential execution of statements. And usually, as you know, if you have a statement, if you have a procedure in your algorithm, usually we represent that in flowcharts as such a rectangular box. So over here, for example, we have two statements. They're being executed sequentially. The first statement is adding the value of grade to total and storing the new total in total. In the second procedure, and second step, we're adding 1 to the value of counter and updating the value of counter. So this is a sequential flow of statements in C. Usually the start, as you have probably seen, the start of a flowchart is usually denoted by an oval, kind of a actually strictly speaking, a rectangle with oval ends on the left and right, called the start block. In between, you can have different statements. different blocks actually, and program ends with a similarly shaped block and a finish or something like that. All right. So in addition to that, the if statement gets if statement and some other statements get their own. Anytime you have a decision to make, and you have a branch in the control flow of your algorithm, we use diamond shape. Something looks like this. So basically have a condition to evaluate. If the condition is true, you move one way. If it's false, you move the other way in the flow chart. All right. So we've already used the if statement. A related statement is the if else selection statement. Another one related to that we'll look at in the hands-on section is the switch statement. So let me just jump ahead a little bit. And yeah, so we'll look at all of these in this section. And yeah, so given that you're already familiar with flowcharts, there's not a lot of new material here for you, but I felt like walking you through this just to give you a revision. So in the next section, we will look at the if else and the if else control statements.